Hello and welcome to the Miko Bits show, and I'm your host, Miko Bits. Today, a very exciting show. We have a co-founder of Solana here, and that's going to be really interesting and hopefully pretty technical. So this is Anatoly Yakovenko, and we're going to be talking about mostly Solana and a little bit about DeFi and Ethereum scalability, I'm sure. Before we get too deep into it, this is an opinion show. It's not for investment advice. So, if you want investment advice, go get a professional. So this is really we're just here hanging out. Before we start, if you're interested in Bitcoin and blockchain, please consider clicking that subscribe button and also click the bell so you can get notifications about future videos that I might post. Thank you. Okay, and without further ado, Anatoly, hey, how are you?
Good. Great to be here.
Excellent. So you have a really big and long career, like Champaign-Urbana, great technical background in CS, and then obviously Qualcomm and a bunch of other things. How did you get first interested in blockchain technologies?
I think every engineer probably in California was aware of Bitcoin and aware of Ethereum. Um, but I think a lot of us looked at it and then like, oh, this is cool, but this will never scale. And this is kind of a toy. I think engineers often miss kind of like the social side of things.
Yeah.
Um, so I've been a like kind of an observer, but in 2017 is when I really started to kind of want to jump into it and not really jumping into crypto. One of the co-founders, Steven, and I had this side project of building out deep learning racks
Wow.
for GPUs,
Fantastic.
but before we had any like customers, we wanted to offset the capital costs of those by mining crypto, right? So you like,
Wow. GPU
I'm sure,
mining.
yeah, but like these weren't like tailored for crypto mining. These were we were designing them for deep learning mining, and then when we didn't have like usage yet, we wanted to basically start mining crypto to pay
Was
for the
it
cost of deploying this.
was it like Ethereum or what kind of mining engine?
Whatever. I think I forget which miner we ran, but it would kind of jump from coin to coin to see whichever was
Oh
most
yeah. Yeah,
profitable.
yeah. That's
Um,
really interesting.
but that's what got me like really to start noodling on proof of work, why it's so slow, why all this stuff is not going to be scalable. And that's how I get into it.
That's fantastic. So, really appreciate that background. So, love to kind of get your perspective on kind of fundamental consensus. Obviously, I think, I'd love to, I think your attitude towards it must be kind of strongly influenced by the design of Solana. Obviously, you wouldn't have made it
Yeah.
the way you did if you didn't have an opinion. So, I'd love to kind of get your kind of take, like, on consensus. Like, how do you,
Yeah.
how do you think about this problem?
I mean, like, I think a lot of the design choices that we have is again based on my career. I spent my majority of my work at Qualcomm,
Yep.
which is a semiconductor company. If you don't know who they are, there's probably something that Qualcomm built in the phone you're holding right now watching this.
Sure.
Um, so because it's a hardware company and I was a software person there, we kind of had this philosophy of really building for the stuff that's going to come out next year, right? Which is always going to be twice as fast, twice as good. So you're always thinking that like the current hardware you're working on is old generation and you're designing for the future. Um, and this is what I thought everybody else was kind of had that mindset. So when I started this like scalability project, I was like terrified everyone was going to take my idea and just run with it, or everyone else is already working on it. But that turns out not to be the case, interestingly enough. And our fundamental approach is again betting that 2 years from now we're going to have twice as much compute. So we should be designing a system that kind of takes advantage of that exponential curve. And the really kind of core idea, this thing called proof of history. Every project needs to have a proof of something, right? So that's like kind of our cheesy marketing term.
Great.
Um, the core idea there is using a verifiable delay function, which is a mathematical construct to measure time before consensus. So this was, so when Steven and I were working on this thing, we called it Tensor Cloud. I got the domain.
That's great. That's a cool
yeah,
brand.
yeah, it was the best name, right? When we were building this, one day we were at this cafe, I had like 2 cups of coffee and a beer, and like I couldn't sleep. And I had this kind of like realization that all this proof of work stuff, instead of setting up the puzzle to try to solve for a single kind of set of bits, that's a hash with like a long set of zeros to start, you can actually just run the same process sequentially, recursively, and generate a data structure by sampling this thing that represents that time was passing somewhere. You can design this puzzle such that it's not parallelizable, that it only runs in a single core. And this came from me trying to figure out, okay, is there a different physical thing that proof of work can be constrained by? Like right now, proof of work is constrained by electricity. What other physical properties can we use? One of them was time. And this is how I kind of stumbled into this thing.
Wow.
I was like, oh, there's a way to construct a data structure that represents time passing. Doesn't matter how much money, how much electricity you have, you have to spend real time. But initially I was thinking maybe this is a replacement for proof of work, but quickly kind of light bulb went off in my head that all the stuff that we worked on at Qualcomm is applicable because wireless networks are fundamentally based around synchronizing around time. So first radio towers, imagine people put these things up and they transmit it at the same time over the same frequency. These electromagnetic waves, when they propagate and interfere with each other, you get noise. So information can be transmitted. And the first protocol people ever built was, why don't we give all these towers a clock and assign them slots and they alternate by time. So tower 1 goes second 1, tower 2 goes on second 2, right?
Is that time division multiplexing? Is that
yeah,
correct?
it's
Okay.
like the most oldest boring protocol ever, right?
Yeah,
it's
TDMA.
like foundation. Yeah, exactly. Foundation of 1G networks.
Awesome.
But really, like that's the basis of all of the stuff. Then everything else is really fancy, like frequency hopping and all those other things. But the first thing that they did is like, let's separate them by time and therefore reduce the interference. And this problem is very similar to how block producers interfere with each other. So when 2 Bitcoin block producers produce a block at the same time, the network doesn't know which one to pick, right? They don't know which fork should be the real canonical fork.
Absolutely, yeah.
So if you actually could separate them by time instead of doing this puzzle, then you can construct a system where you can reduce those slots or that time to be basically as close to the light speed limits of between these nodes. And that's really our goal, is to see if we can get this thing down to 250 millisecond slots. We're at 400 milliseconds right now, and reduce the overhead of producing a block, then synchronizing it. If you've played with our demo on break.solana.com, you can see that we get to an optimistic confirmation in like 1.2 seconds. And this is the entire global set of validators that can confirm that this thing is never going to go away.
So quick question. So obviously Bitcoin is very interested in timestamping, and obviously most consensus algorithms are really interested in time, because time is kind of a bit of an off-chain function. So you kind of have to figure out like how to deal with time. But I guess, are you thinking about this from the perspective of sort of information theory, entropy reversal as a function of computation? Like, is that the kind of base physics type thing?
I mean, when I started really thinking deeper about it, there's this kind of idea that in mathematics, there isn't, we don't have a representation of the arrow of time, right?
Yeah.
There isn't, yeah. So, and this, if you believe that there's, we live in a world where we don't know if there's such a thing as an irreversible function. Right? If you actually look at any physical process, you can reverse it backwards to its original state. And that goes to what you're saying.
It can be hard though.
Yes. So what pre-image resistance does, what cryptography does, is it does all these mathematical tricks that reversing it from the, looking at SHA-256, it's very hard to come up with the input, right? We have some mathematical guarantees, but there is no proof. There's no proof that a quantum process couldn't solve this, right?
Sure.
And that is, we live in a universe where I think my intuition is that there will never be a proof. That's my intuition.
Yeah.
And we live in this universe where we will never know if this is possible or not. And this unknown is going to be kind of interesting feature of our universe. And in that sense, there's always going to be something that has the similar property of like pre-image resistance, where the computation is complex enough to where we don't know how we got there from the output. So this thing, we can always construct this like kind of like weak arrow of time, but like a really hard to break one, right?
Yeah. I mean, I think what people generally assume is they generally assume that without the input of additional energy, that the physics time arrow can be sort of looked at as an entropic function, right? But you know, so I think that's kind of the broader kind of physical boundary.
Yeah, exactly. Yeah. So like this is like a cool thing to think about, right? Like, and the way that I think we've been lucky in that we've really focused on using VDFs as a source of time. A lot of other projects so far using VDFs for randomness. And because we have this global clock, there's just really like 100, you know, at this point, probably nearly 100 years worth of research of how do you leverage this global clock to optimize things, optimize and coordinate people. So these protocols like TDMA, Aloha, and a bunch of other ones, like this is stuff I study in like my intro to communication networks in college.
This is really solid stuff, right? This is like Claude Shannon and like, you know, and the physics underneath, right? That's all information theory. So, but this is really interesting. So I really appreciate it. Obviously, you know, it's so fascinating to really reason about these sort of fundamental consensus algorithms. You know, my fund is invested in Space Mesh, which is, of course, one of the popular kind of space-time consensus mechanisms. I don't know what your thoughts are about that. Is that a cousin, or how do you see?
Yeah, it's totally a cousin. I mean, like, I think, again, at the same time, like, I think this was just in the air. I think I came up with this, not like, I don't want to say it wasn't independent, right? I think these ideas were in the air, and I didn't even know to call it a VDF. But because so many smart people were looking at it with so many different backgrounds that are all common computer science backgrounds, we like all saw very similar things that we could leverage. So like Chia, right, uses a VDF to combine it, and like the reason why you need a VDF plus something else is also in itself interesting, right? Because you can't really use time itself. It's almost like time isn't like it's like two-dimensional, right? It's not three-dimensional. You need something else like to force it like to be like entropy, right? Like proof of work energy.
You can't. There's no. There isn't kind of like this fundamentally decentralized clock anywhere. Like you can't just go ask the you know, it's funny, right? Because there's the whole the kind of network time protocol, right? But it's sort of centralized, right? You're basically asking these atomic clocks that are owned by like the government, right? That's generally what happens, or NIST or somebody, you know. So it's sort of like that there isn't any kind of thing, because you know that produces a huge vector for attack where people can be like, oh, it's 12 p.m. You know, no, it's not. You know, it's like ruined. You know, so that's interesting. Okay, well, so I want to kind of move up a little bit on the stack, right? So I'd love to kind of understand sort of the application layer. I'd love to understand the programming model. I'd love to understand kind of things about, you know, the state of the network. Let's, you know, people are excited about that.
Yeah, we've been live since March. Smart contracts have been live for about 2 months. We don't do a lot of announcements around like this feature's done. Let's give ourselves a gold star. It's more we try to get people to use it. So there's a really fantastic project called Serum that's building central limit order book on chain, and this is a whole new thing. We can maybe get into it in like a few minutes, but I can kind of give you a brief design thesis for our smart contract engine. So again, my background, right? I ended up at Qualcomm in like 2003, and I started working on these feature phones, these old school flip phones that had like 200 megahertz of processing power and 16-bit like instruction sets. So these were like basically microcontrollers by today's standards.
No, it's
um,
great. I think my first PC had let's see, 16K of RAM. I think it was measured in kilohertz, and it's definitely kind of eight bit processor. So
Yeah, so like we were trying to build features for consumers and squeeze them out of like squeeze them into this thing, and I kind
sure.
of learned everything I could about optimizations and hardware, and a lot of what I was excited about working on blockchain was that it's a constrained environment. It's an environment where we can't just spin up a million nodes on AWS. um,
Sure.
so it's more like you're still constrained by the hardware. So how do you use as much of it as you can? So we use techniques for smart contracts that are they've been around forever. It's called isolate database transaction isolation. So you have enough rich data in the transaction itself that's signed to tell you which memory is going to read, which memory is going to write. So you kind of know ahead of time, like what is the part of the state that this thing wants to touch. And if you know that ahead of time, you can schedule all the non-overlapping writes to execute concurrently. So you have a million transactions, you find all the ones that don't write to the same memory at the same time, and then you run all of them in
Is
parallel.
this here's a dippy question. Is this sort of like a sharding type of mindset? I mean, it's a different mindset, but is it a
Yeah,
related
yeah.
art?
It is effectively like we're doing sharding everywhere we can, but before consensus
Yeah,
again,
yeah,
right?
yeah.
We want to do
I no, but
yeah.
I like this obviously, right? Because one of the things that's so important, I like that you're taking this from more like the application side, right? Because if you really kind of think about sharding, one of the things that becomes really an issue is kind of composability across the shard boundaries, right? And so you're actually
Yep.
kind of doing the mapping at the system level as opposed to kind of like, asking developers, which shard do you want to live on, or, how do you, because obviously you can compute as long as you don't cross the shard boundary, but like, why is that
Yep.
a thing? Like, that feels
Yeah.
doesn't feel like it should be a thing.
Yeah, and it actually like it gives a lot of features that people want for decentralization in sharding. Those all become applicable here. Like things like like when you have isolation, you can actually look at the transactions that are all executing the same contract and verify them separately from everyone else because they're isolated, right? Like once you have this like property of like isolation, you don't all the state dependencies, and you don't have to execute the entire state machine to verify just your thing. So you kind of have this nice separation that when often folks talk about like, well, how do we know that the chain is like valid, right? Like there's a bunch of reasons why those arguments are weak, but one of the reasons that I often hear is that like when you have a sharded system, I just verify a single shard at a time, and I know that that shard is valid. Well, if you have transaction isolation, you effectively have contract and program isolation. You can verify that a single program is behaving correctly as it's recorded in the chain, and you have the exact same properties and guarantees. So, what you do get rid of is the complexity of trying to move state between shards
Yeah,
or
yeah, yeah,
users
yeah,
between
yeah, yeah,
shards.
yeah. That's
Um,
badness. That is definitely
and I
potentially
think,
toxic.
yeah, and like fundamentally, I think this even goes back to an even simpler concept that's been around for ages. I don't know. Have you ever heard of this thing called tofu, trust and first use?
No, tell me more about that.
So this is like the oldest scalable security model in the book. If you ever SSH to another computer, it says, "Hey, I've never connected to this IP address, and this is the public key.
Got it.
Do you want to continue?"
Yep.
So as soon as you could hit yes, your computer locally records that public key, and forever it'll allow that connection. It'll trust that public key and that IP address until those change. So you
Got
kind of establish trust on first use,
it.
called tofu. That's a super easy thing for people to scale. It's the same thing that like you and I meet and we want to exchange our signal public keys. We can like hand verify them and trust them on first use, but then we never have to do it again,
Yep.
right? So when a validator connects to a network, especially proof of stake network, we have this thing like where, because it's proof of stake, we have weak subjectivity. We don't know if this is the real Solana network or did somebody steal all the keys and are now running a fake fork, right? We don't have a way to look at the amount of entropy that went into securing this thing, like in proof of work.
Yeah.
We can only look at the set of like public keys and the participants. Well, the first time you connect, the participants that you care about are like Coinbase and Binance and all those financial institutions. You can literally send a transfer from all those institutions to your account and verify that, yes, I'm in the exact same network as Binance and Coinbase. And I don't even care if this is the fake network because this is the one that I care about. It's the one with Binance and Coinbase on it,
Yeah,
right?
yeah, yeah. I like that.
Right? As soon as you've established that you're in the network that you care about, as long as the code and the protocol works, you never have to do that again, right? So that thing, its job is to maintain that property that once you've established trust and first use, that will continue to run. So that's really simple to think about it in a single sharded system because the validator is connected to a single set of large group of validators. They all try to maintain this property, and Binance and Coinbase are always in the same set. And now we're all good, right? Everybody's super connected and we can trust each other, and as long as the nodes keep running. But imagine if you shard this, every time you switch shards, you have to run a bunch of proofs to figure out if the shard you're connecting to can guarantee the same property. That because you're missing the information, like of what was executed, what was changed in that shard, you're now like have to do these really, really complicated proofs and validation. Hey, did these validators actually compute the stake correctly? Did it like a fake Coinbase join? Did they split these network around, right? Like that's the really hard part there. And this is why I think these systems are going to take a long time to develop. I'm not saying it's impossible, but it is a super hard engineering problem, right?
Absolutely.
Because the idea of a single shard verifying its security is like, okay, I'm done, right? I know Coinbase and Binance are in the same spot. That's all I care about. So to me, that like composability doesn't actually. I think the fact that it breaks application composability is almost like the obvious. I think the less obvious thing is that it breaks the most simplest scalable security model that we have, which is this trust and first use.
Yeah.
And that's going to make it much, much harder for those things to get adoption with financial institutions that care about the risk of that going wrong. So we'll see. We'll see how that plays out. And so on the smart contract side,
Yeah.
Because we have a single atomic state, we do have this nice rich property of you can combine any of these applications at any time without requiring any kind of state transfer. You never really have to think about it. You simply like any kind of contracts that want to interact with each other, it's no more expensive than any other transaction.
Yeah, that's very cool. So, in terms of the developer environment, tool chain, programming languages, like what kind of smart contract languages are we talking about for Solana?
Yeah, so we have an environment that's suitable for running multiple virtual machines. When Libra came out, we ported Move as kind of a marketing stunt, right? We
Sure.
actually got it running 4 times faster than the Libra folks.
Nice.
So we can enable other VMs. We're looking into enabling Solidity, but primarily we're focusing on Rust. It's a modern language with a kind of really rapidly growing huge community, and all the fangs are publishing open source Rust code. So I kind of see it as the future of programming, especially systems programming. I think the type system gives you a lot more guarantees about the security of the code and kind of like numerical stability and like those kinds of interfaces that have like delegation and global like dynamic dispatch bugs that we saw in like Balancer and things like that
Yeah.
are much easier to protect yourself against in Rust, where you have static typing and static linkage. So to me, I think it's like Solidity is like has an unbeatable ecosystem, but I think it's going to be its own downfall
How so?
in
How
a lot
so?
of ways. Um, well, this was like again my experience with Brew when we were building these feature phones. We had 50,000 devs building stuff that were paying Qualcomm like astronomical sums of money for a licensing fee, and that changed literally overnight when Android came out with Java-based SDK that was
Yep.
modern. Everybody knew how to build in Java, right, and with simple interfaces. And
I
literally
remember
in like
Brew.
one year, I went from 80% feature phones to 20% feature phones. um, I think Solidity is kind of a little bit because of the cruftiness and like it's single-threaded execution, the kinds of APIs. It's got some legacy code baggage, and people don't realize how quickly that like becomes a problem. And developers are not they're not sticky, to be honest. We're engineers, right? We go learn whatever the cool new tool is and we go build on it if there's an opportunity there. So that stuff is less sticky than people expect in terms of like tooling, all those other things. um, I think it's because we're picking Rust. It's itself a really rapidly growing community.
Yeah,
We're not building our own language and trying to convince people to use it.
sure.
There's just like a lot of stuff we can leverage and enable for folks much quicker.
That's exciting. So I guess I would love to kind of talk about sort of Serum, right? Because I think the thing that people are really looking at the moment is kind of DeFi scalability, Ethereum scalability, all these kind of concerns. So I'd love to kind of unpack Serum.
Yeah, so like because we're really to give you an idea like why we are confident like what we're building with Serum is that a central limit order book has um, a lot of needs for high throughput and low transaction fees. The way market makers work in Ethereum right now is they use AMMs, automatic market makers.
Sure.
There's effectively a pool of liquidity and some mathematical function to decide what the price is of any given swap. So there isn't an order book. There's just a big pile of funds that you can trade between.
Yeah.
Um,
It's sort of
yeah.
a decentralized market making function, right? So it's basically you'll always have a taker, right?
Yep. So the reason why that is great is, like you said, is that you always have a taker, and it's great for projects that are like the long tail of liquidity. But why that's
Yep.
bad is that it's capital inefficient for things that have a lot of liquidity, like Bitcoin, Ethereum, where you have professional market makers that take strategic positions at particular prices that can quickly rebalance.
Yeah.
Um,
Centralized markets haven't worked that way
right.
generally.
Right. So what we're building, what Serum is building for Solana is an implementation of a central limit order book and matching entirely inside a smart contract. So you have like a full order book where liquidity providers can take positions and can move them and change them. And that requires lower latency and high throughput. So they need to be able to send a big pile of transactions to move these positions around as fast as they can. And this is just impossible on Ethereum. This is possible on Solana because we're going to scale this with hardware, right? At no point are we going to, be stuck like, oh, we're hitting capacity limits and now we don't know what to do. We always know what to do. It's just send more CPUs to the validators. So what Serum is building is a marketplace smart contract, right, running on Solana, but that is a central limit order book based market.
Yep.
So it's not an automatic market maker. You can actually take liquidity providers that run whatever strategy they want and try to kind of optimize and squeeze like profit out of these like very high liquidity assets.
Sure.
And that is going to stress like basically every assumption that we made and every promise that we made about being able to scale this thing with hardware. That's going to be put to the test. So we're excited about that because that'll move the technology forward. When I believe like in those early late 2017 days, early 2018 days when I had my pitch deck out, I think I spoke to you, and like the first slide was like, blockchain at NASDAQ speed.
Yeah.
Like I had this like idea that in my head already that these systems, non-proof of work systems, where the store of value is not very clear, these proof of stake systems, I believe, are fundamentally like engines of price discovery, right?
Yep.
Some amount of state, that state has some value, and like the entire world and everybody's trying to squeeze out arbitrage between any points of the state, right, in a single global environment.
Sure.
So in my mind, that these are very complicated engines with financial products, but at the end of the day, they're trying to figure out what the value and price of anything is. So I kind of had this idea in mind when I was building this, and a lot of the design decisions that we made were like, how do we actually move the technology to be as cheap and low latency to the point where you can run something like a NASDAQ on this?
I'm very
And like,
excited.
yeah.
And I think it's, hats off to you because, one of the things that is really kind of amazing is, execution, right? Like that's the real thing, right? I mean, I think your idea is absolutely, a great idea. The thing that I think is even greater is, that you built the thing and you're building another thing, and these things are being built, so that's the greatest part of it all. So the thing that I'm wanting to kind of like probe though is like, so, let's say I'm on Serum and I'm, doing trading on the kind of order book, like what assets should I expect to be trading?
So like we're basically kind of like started this almost like Manhattan like project to build out the ecosystem as soon as um, kind of Sam and I went for it. Like, okay, let's build this thing. Serum is building kind of the marketplace and a lot of the tooling around trading.
Yeah.
Solana's focused on building out tools that are really use case independent and allow like anybody to actually leverage them, not just Serum. The stuff we're focusing on are bridges to other networks and various decentralized custodians and things like that. And there's basically, when you think about what assets can trade on these systems, like especially proof of stake systems, they're all very fungible between each other. It doesn't really matter which network you're on, because once you have a smart contract and you have proof of stake, what you're relying on are signatures from a bunch of participants to approve something. And in a sense, almost all of them are some form of decentralized custodians, right? So to build these bridges between them, Cosmos actually defined this protocol called IBC.
Sure.
And that is a very thorough and very, very thorough and technical spec. So if folks want to get what is the light at the end of the tunnel, I think fundamentally it's going to look like IBC. But the starting point right now is doing everything we can to make this as simple and as easy for users to use. So between Ethereum and Solana, we're building out just a simple multi-sig. M-event signatures required to take custody on Ethereum and generate a token on Solana, right? That's very easy to implement. So there's it's low technical risk, but the trust assumptions are much higher.
So
you have to.
I'm sorry. So effectively, what's happening then in this case is that let's say I have some Ethereum ERC20 token, right? So in a sense, like almost like a Binance, only decentralized, right? Like what I would be doing is effectively depositing that into some kind of a smart contract, right? And on the Ethereum chain, right? So and then what would happen is that contract would have specific kind of quote unquote gateway properties, right? So effectively what I'm doing is I'm sort of demonstrating and locking value on the Ethereum side in order that it might appear on the Solana side.
But so we can even solve that, but the tech, and this is where I think the scope goes from being something as simple as a M-event multisig, where you have higher trust assumptions and decentralized custody and more risk for the user, to the point where you have no trust assumptions, no custody, and the validation that we agreed on a price occurs even on the native chain itself. And I can kind of go through all the steps to get there, right? We're working on all of them concurrently at the same time. And because they have different technical risks, they're all going to kind of execute at a different speed. So this very simple multi-sig, that's very easy to understand, right? I give my token to a contract that's governed by some event participants, and they issue that value on Solana, and then that can be traded. Then you have something like REN or TBTC, where you have networks that are governing this event. So it's not just a known set of event. There is almost its own separate network with a governance structure and its own token in both cases that can take custody. And that works even for something like Bitcoin, where it doesn't have a smart contract at all. The only solution there is decentralized custody.
Yeah.
And that goes from like in various degrees of security to the point where on the Solana chain, we could validate that we can have bonds for these validators for these decentralized networks. And we can validate that when you request your asset to be issued back to you on the native chain, like Bitcoin or Ethereum, that those validators comply with it or they get slashed, because inside Solana, we are running an Ethereum and a Bitcoin-like client that can validate those proofs. So that's kind of like also kind of more complicated, right? A bit more complicated to understand, but also see like the technical risks there are like more solvable. Then the next step of that is running a Solana-like client inside Ethereum.
Right.
Now you almost have like decentralized custody to the level where those custodians are the networks themselves. So now our global set of validators and what they agree to be the state of Solana, those proofs can be executed entirely inside Ethereum in a light client. And the guarantees that you will receive your tokens back into that contract are based on, somebody on Solana has to get slashed for that not to happen. So now you have like the same security guarantees of consensus of both networks. And that is the very high technical risk, because implementing a light client has a lot of nuance. What do you do with a safety violation? What do you do if there's like, just simply the network doesn't produce blocks for a long period of time? All those exit games become much more complicated. So that, to me, that will probably take the longest to execute, but we're working on that as well. And then there's even more interesting approaches where we don't actually move any of the assets on Ethereum. Let's say you and I wanted to trade, do a trade of Curve and Yams, right? There's an order book on Solana for Curve and Yams. We agree on the price and the trade executes there. We can actually take the proof of the trade executing on Solana, executed in a light client on Ethereum, and that proof would force us to do the swap. So as long as both of us have agreed to trust the Solana light client to decide on the price, we don't actually have to move our assets out of custody into some decentralized custodian.
But if you're doing ERC20 to ERC20 or to ETH, like you're still gonna end up like sucking up the gas, right?
But only for a single swap, right? So we don't have to it depends we can do all the trading and price discovery on Solana, but we actually agree to settle. Right. You and I do a bunch of trades, right?
Got it. Totally understand.
All those trades are independent, right? Of anything, so you can
do anything you want, and when you settle, then you pay gas.
Right.
Yeah.
So effectively, but that settlement, to initiate the trading, we don't actually need to move our assets or take risk into a decentralized custodian.
Okay.
That's the cool part, right? Like you and I just agreed to trade on Solana.
Yeah.
And that agreement could be, some amount of ETH that we both lock up in a contract on Ethereum. And that ETH is like kind of our guarantee that if you and I ever come to agreement on a price on Solana, that we're actually going to do the swap of the settlement on Ethereum.
So I think the most kind of popular extant model for cross-chain sort of swap, seems to be things like REN BTC or things like.
So those are decentralized custodians.
Yeah.
This is how I think of it, is like there's like this spectrum of decentralized custody starting from simple multisig to a whole network like REN or TBTC.
Yeah.
That kind of let you peg into the sister chain. But there's if you look at the Serum white paper, there's an even kind of more interesting approach which reduces these custodian risks. And I think that is like the end goal here, because if we don't, if we don't, if an institutional with like, hundreds of millions of dollars worth of stuff on Ethereum, they don't want to take custody risk to trade, right?
Yeah.
All they want to do is just trade.
Yeah.
If we can manage that risk and remove the technical risks there to where those assets never move until settlement occurs, we can actually scale volumes higher faster.
Yeah. You're talking about counterparty risk, which is really important for a bunch of
Right.
things, especially things like people doing arbitrage or these kinds of use cases. Super important.
So the only requirement there is then for us to have enough insurance on the native chain on Ethereum to guarantee that if we ever come to agreement on price, that we go through with the trade. So
Nice.
that amount of margin doesn't have to cover the whole asset. It just really needs to cover the volatility, right? So you and I have, like, let's say some amount of ETH locks up on Ethereum in a contract that says that if there's a Solana light client proof that we came to agreement on a price, that we actually honor that price on Ethereum.
Makes
Does that make
sense.
sense? So it's
Absolutely.
almost like
Absolutely.
Solana itself, the entire network becomes an automatic market maker.
Sure.
So you have
Sure.
this, right? We take this automatic market maker model where you have a simple curve and replace the curve with consensus proof that some agreement on a trade occurred on this external, very hard, very computationally intensive, message intensive thing. Um, and the result of that is really just, oh, here's a proof that a trade happened on Solana. You guys better settle.
Yeah, I mean,
Right? Yeah.
yeah, here's the thing, right? Which is that in some ways, it's not actually kind of radically different from the idea of behind kind of ETH one to ETH two, right? So
Yeah.
you have the emergence of these kind of boundary nodes, and they basically just take care of like this almost like translation, right? It's
I think that, like, fundamentally, unless you're talking about store of value and the security proof of work, all the other proof of stake networks, the block space is fungible. Like, it doesn't really matter where you come to agreement on state. Like, it doesn't matter if it happens on Solana or in ETH2. Um, and why I care about that it doesn't matter is
yeah,
that then the fastest, cheapest network wins, right? Like,
yes,
then it's kind of like we're commoditizing the space faster than anyone else, and if we have the best commodity in terms of like just price per transaction, then we win. And this is kind of like my hardware centric approach: build the fastest silicon, then you win. Doesn't matter what brand is stamped on it.
no, I like that. I mean, it's a really interesting thing, right? Because as you know, like there's just dozens and dozens of kind of novel layer ones. I think that the migration paths are really interesting, and I think what you're really building, with Serum is kind of a killer application, right? So I think that's the kind of promise.
Yep. Yeah. To me, um, that is like the use case that is probably the most important one. Like, I'm willing to bet Solana on that essential limit order book on chain where you can have like real liquidity is the most important use case. In a way, like, I think we are. Um, you can take, what we're building is like if you took Binance and made it permissionless and
Yeah,
programmable and every part of it
yeah,
like open
yep.
to the public, right? I think that's a really, really cool thing for the space because there's an opportunity to kind of start shifting this like power of these centralized exchanges, like kind of start rebalancing it a bit they're never going to go away, but I think they're a little bit they have a little bit too much power right now. Like, it's better if we had a much better split between where liquidity and price discovery occurs. And I'm happy to see like DeFi actually achieving some of that today in Ethereum.
What's your perspective on kind of the user interface stuff? With respect to developing kind of this type of transaction processing interface.
This is like, I mean, like, the nice thing is that, like, because we're open permissionless, anybody can build a UI, and we have a bunch of teams already building like things from like, here's your standard charts with an order book and like very complicated things to like, I just want to swap. I just
Yeah,
just
yeah,
let me
yeah.
single click and swap stuff.
I think
So
that's a nice answer, right? Because if you look at where Binance has gone, like, there's a whole kind of like, oh, do you want to use the basic or the classic, or do you want to use the
yeah,
advanced, or do you want to use the spot? Like, it does all these kind of super different interfaces, and so in a way,
yeah,
like, I think you're headed down a similar path.
right. But like users might not even know that they are swapping on Serum, right? This is like that team and the wallet that they build and how they do the B2C side and attract customers. It's an open protocol. They never have to show that, right? It's really up to them whether they even want to say that it's like powered by Serum or powered by Solana. That's part of the beauty of like open source and protocol development versus like a centralized entity like Binance is trying to build a moat around their brand and everything, right?
Yeah.
Like we can't build a moat, and it is both an advantage and a disadvantage. The disadvantage is harder to compete with a centralized service, but the advantage is that it's harder to it's harder to compete with, right? We don't care who's using it as long as people are using it. So we're really focused on like making that easier and more accessible to folks.
So but it seems to me that like the majority of the benefits are effectively accrued to those who kind of choose to stay, mostly in the Solana universe, to do trading, to get the performance benefits, and really only kind of think about settlement as kind of a specific phase of operation, right? Because, for example, if someone is transacting with Serum, and they're kind of doing so on a single swap basis from the Ethereum side, they're gonna pay gas, and they're gonna pay Ethereum performance penalty, like just for entering your space, doing the trade, and then getting out.
I mean, from the UI, it depends. So the interesting thing with a layer one is that we are connected directly to financial rails and centralized exchanges. And this is the fundamental difference between a layer one and a layer two. So I think that assumption is going to be true for a layer two, where you have to enter a roll up and then exit it. What's cool about a layer one is that because you have access, let's say, to a stable coin where you have direct fiat issuers, right? A fiat backed stable coin, you can take different kinds of settlement risk. You can actually hold something that is liquid and tradable on Solana and have guarantees that you can exit back to, let's say, Tether whenever you want to. So the user can take a pegged asset that's locked up in this thing. They don't actually need to settle back to Ethereum. Like we can do the swap on Solana, right? And we can agree to that. And if we want to, in an institutional like case where the risk may be much higher and they want that settlement to be done, right? They can go through and pay the gas costs. But for somebody somebody that doesn't care, right? That's holding like $20 worth of something, because I have a market that trades against a direct thing that is fiat equivalent. I don't care about swapping back to Ethereum. I can just hold the peg. Like there is like there's effectively one less financial hop is removed in a layer one than in a layer two.
I mean, all of that makes perfect sense to me. But I think what we're agreeing on is that if someone is living in the Ethereum side and then they do kind of they go through kind of the gateway and then they come back to the Ethereum side on a single swap
why
basis.
do they need? What I'm saying is they don't need to come back.
I know. But what I'm saying is, what I'm saying is that the benefits accrue to people who want to live on your side, not on the ones who want to exit every transaction, right? They want to.
We can amortize the effectively the benefits every time they visit Solana and they stay there, right? They get a bunch of benefits, and only when they need to partially go back,
correct,
they need to do so.
Totally. Although it's not as unidirectional as ETH1 to ETH2, which is basically like once you enter the ETH2 universe from staking, you can never go back, right? So it's a bit like more like a fairyland, whereas I think you've got more of a bidirectional system.
I think I think ETH1 is going to almost become like a settlement platform. Like this is where settlement happens. Like kind of like there's equities, right? There's people that do settlement.
Yep.
I don't even know the name of any settlement shops, but there's like a couple big ones. Right? But like all the exciting stuff happens on the execution layer, right? Where price discovery occurs, where trade, where orders flow and things like that. So
Yeah.
that's where like a lot of the innovation happens. Settlement is like, okay, we've come to agreement. Let's go actually get the accountants involved and make sure that these things change hands.
No, absolutely. That's exactly how NASDAQ works. It's exactly how the ICE New York Stock Exchange works, and settlement's this whole BFD. Like, it's basically all these kind of like counter signatures, and it's just this whole freaking thing, So I agree with you. That's an interesting worldview, and one that seems, likely to play out. I guess the question becomes this, right? So, I think that your broad long-term thesis is sort of about how this competition game sort of settles out, but kind of in the short to midterm, what other systems do you see, and how do you see these other systems, right? Because it feels like there are folks that are kind of chasing the opportunity to manage problems related to ETH scalability. For example, all of the kind of Reddit contests, participants, and obviously a bunch of these like, fairly Professor Coinish layer one types. So, what's your, how do you read like, top five, or, how do you like, Cosmos, and what do you think about Dot, and what do you think about all these different cats kind of chasing the stream?
So Cosmos I'm interested in, not because we can't build our own bridges from Ethereum to Solana. But I think it's interesting because the nuance of there's just kind of a long tail of technical problems that need to be solved. And once somebody solves them, no one's going to want to do it again. Like, so if Cosmos like deploys and runs full IBC, I think even though it can be replicated, just direct connections between chains, it's just going to be too big of a pain to do so until there's enough volume. So I think Cosmos is kind of like almost going to be like the mid to long tail of flow of these assets between networks because of IBC, because it's just too hard to do that again. Yeah. Like, it's just too much work.
I like that.
And like, if you're like entrepreneur and you see like a market, like you see a tool that's already done, you're not going to go compete with it unless it's like the opportunity is there, right? If they've already have a good enough solution, you go move on to something else and use there. So right. I think that might be like, what's it called? The Schelling point, right? Like, yeah. Cosmos is good enough, right? And I think that if they can ship it fast enough, it'll probably work. For all the other stuff, I'm more skeptical. I don't think you can build a store of value without proof of work. Just the idea that as soon as you go into this like multi-party agreement on state, yeah, that's not based on entropy, it's harder for me to trust it. Like I'm not even a Bitcoin maximalist, but I kind of get it. I get their argument.
Well, what about space-time?
Those systems are much harder, so it's possible. But I don't know if you've seen both Chia. I'm not familiar about space-time's like latest designs, but like when you start looking at like anything that has a fisherman proof is weakly subjective and cannot be a store value. That's my feeling. Nice.
Thank you.
Like as soon as you get into that where you have to like fish for problems, it's too complicated.
No fishing.
Yeah. Avalanche is interesting. Like, yep. I think there's like a spectrum where like you have these non-deterministic kind of like, I sample the network and then I think it's safe approaches that are pretty cool. But I don't know if it'll occupy like if that market is big enough to where like a solution like ours, which is deterministic and low latency and has the benefits and problems of PBFT aren't just good enough.
What about Dot?
So I don't know what, like, he's awesome at creating a lot of noise around a single thing. I think the success of Polkadot is not based on their tech. They could have done anything and have gotten as much noise and success.
They literally had a polka dotted white paper. right? Like
Yeah,
the white paper wasn't white; it actually literally had dots
yeah,
on it. It was quite a
yeah.
spectacle.
I think they could have done anything basically and had as much success. So I don't know. I shared security between these things possible. Like again, you're kind of like splitting hairs there. Why would you run Polkadot when you can just run your contract on Solana and not pay to get access to the security?
I like that. I like that. That's good.
Like,
That's good. All
so
right. That's good. I think that's really neat. Well, good. Any other resources, things that people should be following? Obviously, the Solana website.
yeah,
You on Twitter. What else?
yeah. If you go to our website, you can find links to docs, and you could play break.solana.com, and you can smash your keys, and every keystroke sends a transaction. You can see it light up. So you
Wow.
can actually see the network, how fast it is, and like if these are smart contract transactions. So if that like kind of lights up ideas for you, reach out to us. We have grants and stuff to encourage developers to go build whatever crazy thing they think is possible.
That's crazy. Just a real quick kind of question. I saw a video on your website, and you were talking about kind of 5G stuff. So I'd love to get your perspective, especially since you kind of have the kind of technical
Yeah,
background around networks. So I'd love to get the kind of the
yeah. So
TLDR on 5G.
this is like our slowest, like this is our wedge into like corporate America enterprise.
Yeah,
uh, there's an interesting thing with 5G and is that 5G networks, the towers have a range of about like 300-400 feet.
yeah.
So 4G towers have a range of like 30-40 miles. So
That's pretty
it's
big.
just like, yeah, the difference is huge. And to deploy coast to coast 5G network, these major operators like Verizon, Dish, and so forth are looking at like potentially almost a million different providers. Like, you know,
Sure.
if you can, yeah, it's just like every little town might have like a bunch of them, like a bunch of little operators that are running these things. Um, so coordinating them and doing the billing, just billing, it becomes like a kind of a gnarly problem. Imagine you're driving your car, right? Office to your house, your phone still needs to be connected. It's constantly using data. It's constantly switching towers because they're every 500 feet, and it's switching providers. And
Yeah, yeah,
every
yeah, yeah.
provider
They're
needs to
not
be
even
billed
towers,
for,
right?
yeah,
They're
yeah,
more
yeah.
microcells.
Routers. Yeah,
Yeah,
they're routers basically.
yeah.
You're just constantly switching Wi-Fi routers, and everybody needs to be billed appropriately for the amount of data that they use. So it's kind of just a gnarly problem. And if you use cryptographic signatures and sign those requests for access and how much data you're using, you can keep track of all that billing in a very
Yeah.
fraud resistant
Yeah, yeah,
way.
yeah, yeah. I like
Then
this. I like this. This is great.
what stack do you use to scale cryptographic signatures? It happens to be blockchain, right? So this isn't actually blockchain looking for a solution. This is like a real world problem that's complicated that blockchain is a really good solution to solve with.
Oh,
So
it's very
that's why it's
decentralized.
exciting. Yeah.
You're right.
Um,
And it's not guaranteed that like you'll have trust across all the providers, especially with these
they don't.
extremely sketchy providers.
So
Right.
that's a crazy bizarre thing is that like you imagine that these systems are like ruled with an authoritarian fist that nobody cheats at everyone, but in this like in United States, right, these like these small shops will basically tell Verizon, oh, your clients like use 4 GB of data,
No,
when
no,
in
no.
fact
It
they just
reaches
use,
it,
yeah.
it reaches the level. It
Yeah,
reaches the level of click fraud, right?
yeah,
In the sense
exactly,
of
but like
it's so decentralized that like it's not hard to imagine that some scrappy operator could just make margin by like just saying whatever. Yeah, agree.
yeah, exactly, right. So that fraud is like I think like $10 billion or something like here globally. The numbers are hard to calculate, but every time I hear somebody talk about it, it's somewhere between 10 to $30 billion that people are just lying to each other. So these big companies like Verizon and those guys, they really want somebody to solve it to eliminate all of this
No,
because
I
it is
like
one
that.
cost of money. It's a huge headache for them to try to fight it themselves because the building asset databases and all these other things and like these one-off solutions are pretty tough. So that's our long play. It's cool because it's viable. It's hard because it's telecom, which are the most slowest, most boring enterprises that are basically extension of the government. Everywhere you talk to them, they're like kind of connected to the government,
Oh yeah,
local,
yeah,
local,
yeah.
federal, state.
Most countries have country name telecom, right? Like
Yeah,
so
exactly.
they're definitely highly regulated.
Yeah, so it's tough, but there's a big opportunity there, and I think what's cool about it is if we can get these people to do their billing on chain, then I think the finance folks there will quickly realize that they don't need to settle back to fiat
Yeah,
because now they have this really fast, easy to use and deploy money that's
absolutely.
cryptographically secure, right?
Yeah,
So
no, that's definitely like the camel's nose. So
yeah,
that's a big
exactly.
entry point.
Yeah,
Ah, fantastic. Well, really appreciate
awesome.
you spending the time. This has been really fun, and I hope people get some knowledge bits out of it.
Yeah, for sure. Yeah, thank you so much for having me.
Of course, really appreciate this kind of like throwdown because I think it really gets to the kind of the fundamental layer, and that's what matters, I think, to people.
Cool. Yeah.
Awesome. Well, I'll let you know when we put this up, and we'll talk soon.
Great.
Okay. Thank you. Bye.
Take care.